All right, everybody. So next we have our badge life talk with Fizz and Nightclaw. For the beginning of this, they've actually done a video tour of their facility and some other information, so we're going to play that. And then they're going to join us live and answer any questions and talk about what's in the video. So everything should be all set here, and let's get this going.
Hi Defcon, I'm Nightclaw.
And I'm Fizz.
And we're PCBX, a full-featured contract manufacturer based out of Cleveland, Ohio.
We've actually been in business for almost 20 years at this point, and the entire surface mount production line that you see behind us, going through several generations of equipment, was born out of our own frustration of not being able to get short runs of complex circuit boards run at an affordable cost here domestically. So our mission has been to help change that.
We'd like to take you through the process of building a circuit board on our line in our facility.
So as you can tell, this panel is pre-recorded, or at least this portion of it is. However, we are live in the Discord, and we will be doing a question and answer immediately following this video. So come up with some great questions, or throw them out as you're watching the video, and we will wind up addressing those after the pre-recorded portion.
Awesome, let's get started.
Yep, let's go.
After you submit your data and parts start arriving, the process begins here at our X-ray parts counter.
The reason that we X-ray parts count things is because surface mount parts arrive in mass to us. Usually they are on either full or partial 7-inch reels, full or partial 15-inch reels, or for a lot of the jobs, as we'd expect, cut tape. This is what happens when you wind up only ordering a smaller quantity than the manufacturer normally delivers it. Distributors are happy to actually give you cut tape strips of parts. However, there is a lot of chance for error in the parts counting process at the actual distributor. And what we've found many times is that parts will be ordered, they will arrive to us, and they'll be short. So instead of the 500 parts that you actually ordered on a cut tape strip, you'll only have 490. And when it's 11 p.m., we have 99% of the job done, the line suddenly stops because we're short one part. So this allows us to confirm that we have the proper quantity of parts available before we even schedule the line to be set up. Once parts counting has completed, each one of the reels is automatically analyzed using computer vision to identify how many individual little blobs that it can wind up seeing, which winds up giving you an accurate count of how many parts are actually present. Assuming that that is correct, all of the parts then move on to parts loading.
After inventory, the parts come to the loading station, where they're loaded onto state-of-the-art Yamaha pick-and-place feeders. The majority of parts come on an 8mm tape and get loaded onto an 8mm feeder, like so. Each reel will come with some dead space and a leader tape that gets fed into the feeder. The cover tape then gets pulled back. The feeder gets closed. The feeder tape then gets fed into the take-up reel. And that's all there is to it. Our pick-and-place machines can be equipped with quick change cards. These allow a job to be staged offline.
So the board that we're actually going to be showing you running on the line is one of our LED lighting products, and we actually shot additional footage when we were doing a production run earlier this week, so we're going to actually show you a little bit of detail of what happens inside of the machines. But basically these blank circuit boards come from an actual circuit board production house. We don't make these here. It's an entire dirty factory process that is very difficult. We'd like to get there eventually, but not quite there yet. But this is basically what we wind up getting along with the parts, and the job of the line is essentially to take all of these boards and put the parts down onto them. One of the very important things to realize with the actual circuit boards is that every one of the boards has what's called a fiducial on the board, and that allows all of the machines in the line to be able to automatically register to the proper locations on these boards, because all of the processes have to be very accurately registered, especially with some of the tinier, smaller pitch parts that wind up actually getting used on circuit boards these days. So these boards are loaded into the head of our line here. This is a stencil printer, and the stencil printer winds up actually loading these particular foils, which are laser cut, and if you see, this board actually lines up to the apertures that are on the stencil. So each one of these apertures is a place where the solder paste is able to wind up getting printed. And as you can see, this is the printing process that's going on here. A board is loaded into the machine. The board located and registered under the stencil. The machine has cameras that are actually looking for those fiducials. It's looking for fiducials on the stencil. It's lining those up, and then you can see the blades wind up actually coming down, and they sweep the solder paste bead, which the solder paste is the kind of a grayish looking substance. It's about the consistency of feel of toothpaste, and it moves on to the next stage in the line. Once the boards are printed, they actually pass into the next machine, which is 3D solder paste inspection. This is a really neat piece of equipment that does 3D metrology on the actual print. It is able to use a series of cameras and projectors to build a 3D model of every one of the solder paste deposits on the circuit board and validate the volume and presence of that solder paste. Because a lot of the parts that we wind up dealing with are incredibly small or happen to be on the bottom of components where they're not actually visible in normal circumstances, or both, we want to make sure that the solder paste print is absolutely perfect before it passes on to the next piece of equipment in the line. This piece of equipment allows us to validate that, and in some cases, this is able to actually use a small solder paste jet in the front to repair small amounts of deposits that may not have gotten printed correctly. Once the boards pass 3D solder paste inspection, they pass into the heart of the operation, which is our two Yamaha pick and place machines. Our first machine here will hold up to 128 8mm feeders, and it actually has two separate gantries, each with 10 separate pick heads that are all able to come down and simultaneously grab parts and put them onto the boards. You can actually see in the video here of building the board on the line, there's actually two separate stages, so the machine is able to work on two parts of the board simultaneously and then trade off when each one of those sections is done. The placement rate on these machines is up to about 90,000 components placed per hour on the first machine and about 20,000 on the second machine. Everything is actually load balanced with the idea that the boards need to actually cycle between the machines and the placement heads as evenly as possible to get things through the line as quickly as possible. A lot of people ask what the accuracy is of the machines. It's approximately plus and minus 35 microns at 3 sigma, which is basically a very, very tiny fraction of the smallest size resistor that can actually be placed on a board on the worst possible placement of the bell curve. So, in other words, very, very accurate. A lot of people actually ask about the machines and the flashes that you're actually seeing. Those are actually camera systems that are imaging the parts as they're picked up on the heads in order to correct the X, Y, and rotation that naturally happens as a part's picked up out of the tape and is carried over on the head before the machine actually places them on the boards. Again, these machines wind up actually looking at fiducials on the boards as they flow in to be able to know where to actually line up all the geometry for the placement. There's a lot of really cool things that the machines do, including full barcode scanning systems that wind up actually allowing us to use and confirm traceability on parts and feeders and making sure that the correct things are loaded into the correct spots, because one of the things that you're always worried about in a setup like this is that fast machines can make a lot of garbage very quickly. Once the boards come out of our pick-in places, they proceed across our inspection conveyor, which gives us a last-minute chance to look at anything on the board before it actually proceeds into the oven. Now, our oven is basically a 7-zone oversized pizza oven that runs Windows 95 because it's an oven and you really have to put 14 set points and a speed in it, so not exactly tasking thing for the operating system. But as the oven actually winds up running the boards through, we wind up actually preheating the paste. It causes the flux in the paste to activate, burn off any oxidation or volatiles, and essentially sets the solder paste up to become liquid and to reflow all the joints on the circuit board. Now, it sounds really simple, and in theory, it pretty much is. However, in practice, one of the things that's very important for us to be able to make sure is correct is the actual thermal profile that the boards and the solder paste experience in the 3 minutes or so that it takes to go through the oven. To be able to actually carefully confirm that, we wind up using this, which is actually called an oven profiler. This is a series of thermocouples that are attached to a test article board, and in fact this die actually is wireless, so we can see the results in real time as it proceeds through. This allows us to make sure that we are inside of the process window for the solder paste to make sure that it's going to reflow properly, because different masses of components and different sizes of circuit boards will actually affect how fast that heat is taken up. This also makes sure that we're not exceeding the maximum thermal specification for particular parts. Things like LEDs and such are actually very, very sensitive to being overheated and can become unreliable if you cook them too much. So using this, plus the oven settings and some predictive software, plus the specification sheets for the solder paste and the components, allows us to make sure that the oven profile is exactly where it needs to be in order for perfect solder joints to form. Once the boards wind up coming out of the oven, they go into the final piece of equipment in our line, which is a quality assurance device called a 3D automated optical inspection. This is actually a really cool piece of equipment that winds up having 5 cameras and 4 DLP projectors on this head. This winds up actually moving around and imaging the board in all of the areas of interest where we want to actually do inspections of components. This winds up using a sophisticated system of projection and cameras to create a 3D model accurate to about 7 microns in X and Y and 0.2 microns in Z. This machine is able to look at each component and each solder joint, verify proper operation, formation of the solder joints, OCRing of text, orientation of components, and a whole bunch of other factors that are important to validating the boards. A lot of designs that we wind up actually building, if we aren't able to functional test them in-house, we can actually only do a visual inspection of the board. So it's important for us to be able to verify that all of the articles on the boards are exactly as we expect them to be, so when they wind up making it to the end customer, they can power up their boards and hopefully they wind up doing exactly what they're supposed to. As a final point of inspection on boards that require it, we actually have an X-ray system. This Nicolet will allow us to look under and through parts, so BGAs, CSPs, QFNs, DFNs, LGAs, parts that basically have joints that are hidden because it's a bottom terminated component. So the magnification on this thing is actually pretty good. It'll allow us to actually zoom in to be able to see bond wires and individual vias.
At PCBX, we also possess capability to do selective solder for through-hole parts applications. During this process, through-hole parts are loaded into PCBs. They then pass into our selective solder machine, which, using a bead of solder, runs across the board and solders the through-hole components in place. Our selective solder uses a water-soluble flux, which means that the boards then have to be cleaned and dried before they are complete.
The newest addition to our surface mount line is the My600 Pastejet printer. Much as the name implies, this is in fact a printer that jets paste, about 1 million dots per hour when running at full rate. The advantages of this printer are the ability to eliminate the requirement for stainless steel foil stencils. This machine takes the place of the machine that you saw at the beginning of the line and is particularly useful for short run or low volume prototyping.
So while editing this, we realized that we accidentally made kind of a crappy looking corporate pitch video, which was not our intent, but we chalked that up to the fact that you can only stand in front of equipment and talk about what it does so much until it starts looking like that. So sorry, that certainly was not our intention. We do hope you guys wound up enjoying seeing some of the detailed process video and a general overview of what happens on the surface mount line. There is so much that could possibly be covered on this that it's really kind of just impossible to put into a quick set of generalizations. So at this point, we're going to take this over to the live Q&A portion, and we would love to be able to answer your questions that you may have about what you saw in the video or anything else regarding circuit board surface mount assembly process.
Okay, you guys should be live.
Hey Defcon.
Hey Defcon.
So we hope you enjoyed our video. That we got slightly self-conscious when we were editing it. And we're like, wow, this looks way too corporate. So, but you know, like I said, there's only so many ways you can present the machines without it kind of looking like that. So hope you guys enjoyed. No, we actually do not have lights set up in here right now. We had all the lights set up when we were filming everything previously. If you guys have some Q&A or things like that, we figure we can kind of just, since we're here, we can wind up actually kind of addressing questions that you guys have. Some great questions about the new and used stuff. Yeah, there's a surprising amount of used equipment that's on the market, and a lot of times you can luck out really good on it, depending on what you're looking for. There are actually equipment companies that specialize in used equipment, so even like pick and places and such, like our third generation of pick and places were quads, and those are still out there. And if you're doing to like, you know, 0603 and bigger parts, you can get those machines pretty readily for very cheap. Like we liquidated like 500 feeders that we had for those at one point, and we were selling the feeders for like $5 or $10 a piece, because that's what we got them for when we actually got the whole set of stuff.
If you can snag equipment out of the medical or aerospace industries, it may be high hours on the machines, but most of that equipment has been very well cared for and very well serviced to meet the demands of those industries.
Yeah,
so
absolutely.
A lot of the time it's like getting an almost new machine just because of the amount of maintenance.
But because it's DEF CON, I have to make this joke. This is what you wind up drinking when your used equipment, or I'm sorry, your new equipment has problems, and this is what you wind up drinking when your used equipment has problems. So, yeah, cheers. I'm not going to actually... Oh, I guess you're going to go for it.
I'm going for it.
Cheers. All right. All right, it's real con now. Yeah, so actually, great question with that. The do you want me to grab? I guess I can just pick this up and move it around. So, yeah. So one of the questions, our fogger actually wound up kicking on there at the, I guess, appropriate time. So these are actually ultrasonic fogging systems. So this actually uses compressed air as well as deionized water, and that actually runs back to a humidity-controlled solenoid. So these actually allow us to keep the production floor at between about 40 and 50% relative humidity year-round, which the really important thing with that, we have air conditioning that you can see that's actually above us here, so temperature of the production floor stays the same. But one of the major parts about the humidity is actually for certain processes, solder paste especially is hygroscopic, so it will actually absorb water out of the air, which you're like, well, wouldn't you want lower humidity for that? Yes, but we would actually rather have the same humidity year-round, which means that the print process of the stencil printer that is behind us, this guy that uses the traditional stencils, isn't going to change. So even though the paste life might be a little bit shorter, like say, you know, during the summer versus the winter, if the humidity wasn't controlled, we would prefer to actually have it just all be consistently a little bit shorter. There's also things like electrostatic dissipative sort of stuff. You can see our floors here are blue ESD conductive epoxy, and actually when you wind up walking onto the production floors, we have these little step-on heel testers that wind up actually going through your shoes, which we actually have ESD shoes that Reebok makes that make sure that you're grounded at all times, but actually having about 40 or 50% relative humidity on the floor also helps to make sure that static in general stays lower. Also for things like RTV curing.
We do have a question here from Puma Cat, who wants to know if, no, this is actually a question from Cheese, wants to know what industries we serve outside of DEF CON and Badge Life.
Oh, is there any industries outside of Defcon?
I mean, there's the entertainment
Yeah,
industry.
yeah,
We
fair
do a lot
enough.
of, work
No,
for-
I'm just saying in a general existential sense, because badge life is life. No, so we do a lot of work for primarily special effects. Certain theme parks that are in Florida and California are what we do a lot of work for, and in fact. Sort of PCBX evolved out of my original company that I started for doing special effects work, and we kind of have all of this stuff back here because a lot of the work that we were doing requires short runs, like a couple dozen to a couple hundred circuit boards turned very, very quickly, and we literally just could not find anyone else to sort of take care of that for us, and turn time was generally the issue with that, so we're like, well, let's bring it in-house, and it's great because now we can kind of push it through as fast as we need to. So primarily entertainment, but we, since we've been doing PCBX as sort of a general contract manufacturing company, we actually wind up assembling essentially boards for anyone that winds up needing it. A lot of prototype stuff, a lot of interesting products that essentially just have embedded system stuff. There's one company that we produce a control card for that actually does like industrial monitoring for construction sites. They actually have a really cool product that detects the EM field that comes off of high tension wires, so they're able to actually put their units like up along the boom of like construction cranes, and it can detect if it's getting in proximity of high voltage wires. So we build some of the control cards that actually wind up going into those systems. So yeah, a whole bunch of different stuff.
Bernard Kahn actually has a really good question.
Let's see. What is your ideal product volume? When accepting orders, do you prefer something that is, say, 1,000 units, 100 units, or do you also work on projects with 5 units? Hey, wonderful question. So the 100 to 1,000 is always great because that's a real butter zone for us. The big thing that we always have to deal with the surface mount line is that there's a certain amount of setup overhead that's required to get it running. But once it is running, and by that I mean kind of proofing out the first articles, loading all the parts onto it, we can rip through boards very, very quickly. But the setup is always kind of what kills it. But part of the thing with having the Pastejet that you saw in the video that we'll have online here in the next couple weeks, the intention for that is we would like to actually start offering a service so that if people need something like 1 to 5 boards assembled, we'll actually Pastejet the paste onto the board and then hand build or hand assemble the board rather, to get the parts down onto it, run it through reflow, and then send it out, because then in literally a couple hours or a day or so turn time, we can get the stuff assembled, because we're not going to spend 2 or 3 days to get the line set up to run 5 boards for it to be like, 3 minutes on the machine, and then you have to tear everything back down again. So yeah, ideally a couple dozen to a couple hundred is really kind of the butter zone, but we're happy to kind of quote whatever you need, and our real mission is to try to get the price and turn time down for domestic assembly however possible. So we've been doing a lot of work to automate parts of the process. Yamaha's front end for the machines is kind of garbage, but the really cool thing is they use XML for data exchange. So we've started creating a lot of basically software tools to help us process the data more quickly and more streamlined to just turn things around for people quicker.
We just jumped over to monitoring the Talk QA Submissions Badge Life channel. If you want to ask a question, jump over there in Discord.
Yeah, so and then there, how would you get started into a career like this? So the really weird thing with this is that it's kind of almost a hard thing to get into in the formal sense. There are actually some universities that are starting to offer manufacturing degrees that are specific to this. We're actually fortunate that there is a community college near us that actually has a full-blown program, and actually it's a full accredited bachelor's program, that specifically covers all of this sort of technology, and they literally have the same equivalent caliber of the machines that we have here. It's a smaller program, but they also have like a full MEMS lab. They actually do silicon and wire bonding, crazy stuff like that. So there are some options for formal sort of introduction to it, but there's so many people that are sort of up and coming right now that are literally kind of just learning it on their own. That was sort of the path that I did, because when I started into this stuff about 20 years ago, there wasn't that information out there on the internet and a zillion videos on YouTube on all of this stuff. So really getting kind of a solid idea of how the stuff winds up working, surface mount soldering, board design, things like that, you can honestly kind of start picking up on your own. And honestly, if you're interested in this type of stuff, I would say see if you can find a company that's in your area that does contract manufacturing, and see if they have obviously intern positions is a common way to get into that, or if they're hiring, or ask them what they would recommend for getting under your belt to be able to get hired on with them. It's one of those where for a lot of this stuff you really just kind of have to get your hands dirty with it and jump into it and kind of learn the equipment and the process and things like that.
Yeah, she's just asked what kinds of things you should avoid when designing your boards for assembly. We could probably do a 2-hour talk on that.
Yeah. Yeah.
Biggest thing, honestly, like the biggest thing is somebody running a line. Please have good fiducials on your boards.
Yeah.
Just round, clear, good fiducials. That's one of the biggest things we run into is we'll get boards that have no FIDs, or the FIDs were an afterthought. And just trying to get all of the equipment to consistently lock on is the biggest part of this manufacturing process.
Yeah, and especially with things like if they're not actually ENIG boards where they're hot air surface leveled, the FIDs, like the board house honestly does not care about the FIDs that much as other things. Like there's no electrical test. If it's not shaped the correct way, they don't care. If it's not been hot air surface leveled correctly and it's a little dome and it reflects the light differently, they don't care. Our equipment cares, and it'll basically bitch at you and say, nope, not going to do it.
Or the equipment is a robot, so depending on the tolerance that it's set for the FID, it may not properly lock on, and then you get boards that are built with a skew or an offset.
Yeah. Let's see. Are you planning on open sourcing the software you develop? The problem is it's more of what we're building is kind of an EMS ingress sort of system. So unless you actually happen to have this exact equipment, it's not really going to be of particular use to you. We've fought with a lot of different things, like trying to figure out how do we tie inventory together and parts and bills of materials and like all of this type of stuff. And there's no good solutions that are really out there that we've found. So we've sort of just, we've been taking all parts of that and putting our stuff together kind of at our end to solve those particular issues. So I'm a big supporter of open source stuff. I'm just not particularly sure how useful it would be to other folks. Mm-hmm. What kind of a nightmare is it or is it not to run flexible PCBs through your line?
All about jigging.
Yeah.
It's about holding and supporting the board.
And unfortunately, because things are running a little bit further behind, if you've seen the teasers for the new Defcon Furries badge this year, that is actually going to be on a flex board. We were not sure when we were going to run that because we were going to hope to put some footage of running that badge into this year's presentation, but we'll probably wind up filming some stuff, so if you guys are interested, we can definitely show you that. But yeah, for running flex boards, it kind of comes down to how well it's supported, because it has to effectively be treated as a rigid board going through the system. So a lot of times, depending on the geometry, that board can actually be made in sort of a rigid frame, or if it's something like a rigid flex board, you can run it through like a flex board. If it's entirely all flex, then usually there is a pallet that the board is put onto, and that is usually made out of a high temperature plastic called Torlon that you can machine, and essentially you kind of just have a jig. So you set the board down, it has little tension grippers that pull it out, and it essentially just pulls it and supports it as it goes through the line.
Could show our super ghetto jig.
Oh, I'm not sure where it is right now, okay. So let's keep moving on here. Oh, customer, my glasses just broke too. Hooray! I gotta see the epoxy held for 15 minutes. That's why they call it 15-minute epoxy. Let's see. What is the most challenging thing about designing boards? By the way, I love that shirt. Must be your shirt, because mine's very, yeah. Let's see. Challenging thing about designing boards, honestly, and this is something that we really try to help folks out with, is I would say the most challenging thing on designing boards is design for manufacture and learning that, because really, as long as your circuit board works, like functionally, mechanically, electrically, there's many paths to laying out a circuit board and making it functional. Where the key difference comes in is design for manufacturability aspects, and what by that we mean designing the circuit board in a way that it can be put through the line, and there's small concessions that a lot of times you may not think about if you're not used to the process of what happens on a production floor like this. So for instance, like panelizing boards is always a big thing. It's like, okay, how do we pack multiple boards together onto a panel? Sometimes if they're odd shapes, it becomes a little bit more difficult to support the boards. But if you have something like, okay, well, if we can have straight lines, it means that we can score the board and snap it apart. But we can't do that if there's things like switches or connectors that are overhanging the edges of the board. So there's a lot of times where you can tweak very small small aspects of the board, like what components you use or where they're placed, like things that from a general execution standpoint of your circuit board wouldn't affect the functionality, but it would definitely significantly affect the manufacturability. So if you send us boards and we review board Gerber sets for you, that's one of the things that I'll always do is we'll point out, hey, could you possibly move this stuff around a little bit or change this or do this, because it would just make it way easier to manufacture, and if it's easier to manufacture, that means we can do it for a lower price. Let's see. It's very specific from what I've looked at on Fox and some other news networks. Sorry.
Yeah, open source.
Let's see.
Top 2 problems. We kind of got into that. Another one that we've seen occasionally actually has to do with the oven reflow process, where some people on their boards will put super high mass parts right next to like little O2, O1 capacitors. So you have just a massive inductor. So to actually get enough heat into the board to reflow that inductor, you're then potentially damaging the tiny little parts next to it. It's like thinking about thermal management on your board, but that gets really complicated in some ways.
Yeah, and sometimes it can't be avoided. It's actually one of the other things with the Pastejet, because worth pointing out is that a lot of times, like, you don't really throw away your normal stencil printer for the Pastejet because it's the stencil printer that does the normal passes through the foil. It is way faster. Like, you can get them down to about an 8-second cycle time for really high volume lines, and regardless, even our older printer will go much faster than the jet printer based on how much detail there is. However, one of the things that you wind up fighting with stencils is the smaller the components get, the thinner that the actual foil has to be. We typically run 4/1000 thick for some of our stuff, but if you get down to really small components, sometimes it may be 3/1000. But then you have this balance issue, because a lot of times you're trying to print these really tiny parts like 01, 005s or 02, 01s, but then you got these big honking like inductors that need these humongous pads that are next to them, and you can't do both. It's you either have really good printing for the small stuff and not enough volume on the big stuff, or the perfect volume on the big stuff and way too much volume on the small stuff. So one of the neat things that the Pastejet lets you do is you can do like 95% of your entire print using the standard traditional process, and then go back and use the Pastejet to actually go on and sort of augment the process of printing in the areas that needs it specifically.
Hello, Fox. If I had all of the money in the world to spend on equipment, the first thing I'd buy is a new stencil printer. All of your problems start at that print process.
Yeah,
and that's not dialed in and perfect. It's just all an uphill battle from there.
Yeah, and the Ultra Print that we have right now, it is an older machine, but this is one that actually came out of medical, so it was in great used condition. It's the next thing to actually be changed out on the line. And mainly it's just, there's more stuff that you kind of just have to manually fiddle with this. On the newer machines, everything is closed loop, so when you set the tension and settings and pressure and things like that, it's like set to the exact same amount of, like, you know, Newton meters of force and such, or newtons of force to just basically make the process invariant. So like the stencil printer here works really well, but the nice thing that's paired with this and what we really were able to kind of eke out the best performance on the stencil printer is having 3D solder paste inspection, because the 3D SPI is sort of like having a dashboard for your printer, because you sort of really don't have good confidence in how good or bad the prints are from the printer, especially over the course of several hours of like printing boards. The SPI will let you catch that and adjust and figure out what's going. So there's you know, used equipment is great. It just depends on where you have to set your expectations and what you're wanting to do with it and how much you want to babysit it continuously in some cases. Like quads, great picking places. You'll need to stand next to that machine continuously. Our old quad was named Roxanne because they had little totem poles, and it was named Roxanne because it would always put on the red light and stop and demand your attention. So there you go.
How hard has it been competing with overseas manufacturers?
So generally we try not to. Price point wise, we would like to try to get closer, but you're just not going to compete with the labor that's out there. We're intending to try to get more competitive based on getting jobs in and through the line faster, but it's one of those where we're not trying to go after the business where they're only concerned about the price. It's just not really possible to do.
If all you're concerned about is price and volume, and you can afford to send an engineer to China to set up a factory to produce your board there, there's no way that we're going to compete with that.
Yeah,
but if you just need short runs, or you even need volume, but you're a small shop, it's going to be easier to deal with us than to deal with an overseas company.
Yeah, and some of what we try to bring to the table is the fact that it's like you're talking directly to us when we're running boards for you, so it's like there's a good communication through the entire process. Any kind of special accommodations, things that we find while running it, questions that we've got, we tend to try to bring a lot of these extra added benefits to the thing. So our joke has sort of been, if you don't fab domestically now, you'll fab domestically eventually, because most people either they have a really good experience or they have such a bad experience with China that it's just, it winds up coming back here. So it's, you have to kind of know the market that you're going after.
How many people does it take to run a line like the one that we have? So worst case, one person. I've definitely, to get jobs out the door, been the only person here running the line on my own, preferably two. That you can have somebody at the head of the line managing sort of the printer to the picking places, and then somebody else managing oven and AOI. You can streamline the process to the point where it's running more continuously.
Yeah,
with
and
one person, I'm kind of running around like a chicken with its head cut off, trying to manage too many things.
And for ingress and setup of the jobs, generally it's 2 to 3 people because there's multiple tasks that can be happening simultaneously. Like feeder loading is a completely parallelizable process.
Yep.
The X-ray parts counting at the beginning of it is usually one person that's cycling through that, but if they can hand those parts off to somebody to load feeders immediately, that's helpful. Having stuff like the feeder exchange system that you saw allows us to stage one job while another one is basically running in the line. So the idea is to try to switch that stuff around as quickly as possible. One of the things that people also don't realize until you've done it with the pick and place, because you always think about it in the high level thing, you're like, oh, the pick and place, it picks up the parts, it puts them on the door. It's like, fundamentally, yes, but the vision system and what you're trying to do to pick up those parts reliably and recognize them, correct for them, put them down, until it's dialed in, the machine just wants to be like, your worst enemy, because it'll do 25 placements perfectly fine with a weird part or a connector, and then it'll just start having random things, and you're like, oh, okay, and then you have to dial the vision system in a little bit more, and then it'll run further, and it'll run better, but then it'll be like, 500 of them in, and it'll still stop, and you're like, okay, tweak. So it's like, by the time you get it to the end of the job, it's running wonderfully, and it's like, the thing that sucks is like when we're not able to rerun jobs in the future, because it's like by the time you get to the last board, the line is running perfectly. So it's like for doing reorders for people, it becomes really cheap because you literally throw all the stuff back on the machine, start running it, and you're just up and going. But for like bring up of new products, it's always challenging if we've not seen that particular part or connector or weird thing before.
Style of part.
Yeah, it's also for things like 3D AOI, it's wonderful in the way of being able to do quality assurance, but like anything else, you have to do a whole setup on it, and we usually say we need about 12 articles or about a dozen or so to be able to get a good enough sample size to know where to dial the windows in on basically the automated inspection, because you'll start getting a ton of false calls if your windows are too tight, but you never want to make them wider than necessary, because then you potentially would start missing certain things.
Failures like tombstoning. So not really tombstoning at this point. We might see a tombstone every 20,000 capacitors or something.
Yeah, if that.
That's a rare one for us. We have seen all sorts of failures. If you can imagine it, we've probably seen it and dealt with it at some point. But we don't get a lot of failures at this point. A lot of that comes down to oven profiling. When we brought in the profiler, a lot of those things like tombstoning and graping on solder paste, we stopped seeing altogether.
Yeah, and also things like the 3D solder paste inspection with the print. Like if your print is good and it's a well-designed board, failures are honestly like somewhere off in probably 4 or 5 decimal places, to be completely honest, in like number of components. Like tombstones on actual passives, I would have to say we see maybe like less than 10 over an entire year.
Rare.
So yeah, some of that's also like the board design, because you'll have besides the printing process, things like just thermal imbalancing or thermal balancing of the copper. Like if we get a board into us and we see something like there's a huge ground plane and there's just like exposed areas in the solder mask for one side of the like say capacitors or resistors or something, and then they connect off to a pad and there's just a little trace going off of it, you're going to have a huge amount of heat sink on one side and you're going to have just this little tiny bit on the other. So one side is going to heat up and reflow a little bit faster, and that's what's going to be have the tendency to cause a tombstone, but also there's a lot of things like with the oven in having a proper preheat. So even if we do have boards that have those large sections of copper, because sometimes it's unavoidable, we can tweak the actual profile to help better accommodate for weirdities like that.
Have you had any problems with the machines? Not so much. We did have a I guess it was a motor controller in the pick and place.
Yeah, there's stuff that occasionally will just go kind of bad on them, and it's like honestly, you have that with almost any equipment. Obviously, more so with used stuff. Like the great thing about like the oven right now is it's literally an oven. It's a bunch of like heating platens, a bunch of SCRs, and some control logic, and like a card in there. So there's like not a whole lot that you can't just quickly stick a multimeter in there and sort of diagnose. On all of the equipment that tends to be more core to the operation, like the pick and places and such, that's why all of that equipment is bought brand new, because then you can literally pick up the phone almost 24 hours a day, get service and support, and then spare parts are generally stocked in the US so they can be to you the next day.
Yamaha is great as a company. They really legitimately care about their equipment out in the field.
Yeah,
if you call them and say, hey, your equipment's not working, somebody's at your shop like beating the door down to fix it. Like,
yeah, so they've been great with that. So it's I think like with the Yamahas, like the worst we had is like we had a servo motor that went out. It was actually for the width adjustment on the conveyors. For some reason, it was just having some kind of random issues. So.
It was thinking that the conveyor had stopped and was throwing like a high torque error.
Yeah, so it was change the motor out, and a lot of times that stuff's under warranty anyways. So that's kind of another good thing about buying them new where possible.
What's the worst thing about working with PCBs? I hate solder paste. It gets on like your hands, it gets in your clothes, it gets on everything. I think it's just annoying and obnoxious, but some of that's just keeping the machines clean and wearing gloves.
Yeah, it's like worst thing about working with PCBs. I think probably just the sheer number of ways that things can go wrong. I've always joked that it's like additive manufacturing is me personally is like the most difficult form of manufacturing. So that also extends to things like either putting parts down onto circuit boards or 3D printing. It's like not to say that things like when you're machining or CNC milling and you're subtracting material away from things, it has its own set of challenges. But just in my general experience with all this stuff, anytime you have additive manufacturing, it's way more difficult than subtractive.
Can you do laser direct PCB marking? We can't at the moment because we don't have a machine for it. We can do custom label and label application with the pick and place machine.
Yeah, so right now we actually wind up using zebra labels. We actually have high temperature. It's a Kapton sort of substrate. So for a lot of boards that we actually put through the line, we actually put a little PCBX sticker onto all those boards automatically for just traceability purposes for us. Direct laser marking is something that we have explored, but one of the difficulties with that is that you actually have to have certain controlled criteria on your circuit boards to be able to make the marking actually visible to anything through the process that might need to see it. So things like differences in LPI mask, the color, even the manufacturer of the LPI mask at the board house will differ the results for how the boards are done. So most times when companies are... Oh,
that's
there you go.
That's an example of our little PCBX.
Yeah, it's not focusing really well. It's tiny.
Yeah,
but the nice thing is this is print. It's a printed label, but it's printed on a substrate that we can put that through the reflow oven and no problems whatsoever. So if we have custom needs for boards for people, we can just do actual labels up. We've also started doing things like doing a panel barcode that sits in one of the upper rails of the panel that lets us use to tie together data sets on SPI, AOI, things like that. So yeah. So long story short on that is yes, you could do laser marking. We don't do it right now because there's too many problems associated with it, and most people that are laser marking are doing that on boards that they're regularly running for their own purposes.
Hello Fox asks, what is the next thing that they should throw at us after flex boards? I want to do chip on chip. Now that we have now that we have the
Pastejet,
we can actually put components on top of components.
Yeah, so because it's like with a lot of the modern cell phone stuff, if you see it, they're literally stacked BGAs. So they'll take the processor that'll have the BGA ball grid that goes down onto the board, and then like around the periphery, they have another set of pads for like memory to stack on top of that part. And the difficulty with that is always like, okay, well, how do you get the paste stenciled onto that, because you know you can only generally print at one level, but with the Pastejet you can actually have it go ahead and deposit stuff at differing heights. It'll do cavity printing, stuff like that. So we actually were doing we're looking at doing some rigid flex boards also for Loyal on a cool project that he's working on, which arguably that's probably easier than flex. So I think, you know, if we can lick the flex type of stuff, there's not a whole lot that you can throw at it that's going to be too terribly more exotic than that. Let's see. Yes, let's see. Do you do any enclosure design, prototyping, modding, 3D printing, things like LED light pipes, battery compartments? So for products that we design internally here for customers, we will do that kind of work. Generally, for the PCBX side of things, we try to stay focused sort of just on PCB assembly because it's what we do well. However, for kind of auxiliary parts like light pipes and sometimes like switches or even mechanical mounting hardware, there's actually a large amount of that stuff that is available as like surface mountable parts. So if your board needs things like standoffs or threaded inserts or whatnot, a lot of times you can actually get that stuff on tape and reel, and we can kind of put it together. Depending on the project, if there's enough volume or it makes sense, we may be able to do like a box build sort of thing where it goes into an enclosure and such. But again, what we've really focused on just with streamlining everything here is just PCB assembly with first of all surface mount. We can do through hole. The soldering is an automated process, but somebody still has to actually sit there and stuff the parts into the board. So as we try to tell everybody, it's like try to just go surface mount with as much stuff as you can because it's always way less expensive. Let's see. Oh, we're already time, so I'm going to cut off the QA here. Yeah, thank you so much. I appreciate you guys joining us for the panel here, and we're happy to stick around and do some more questions if people want to keep throwing them out here.
But yeah, I think we can answer some questions in the Discord here if they were going to cut the stream and move on to the next presenter.
Cool. Well, thanks guys.
Thanks everybody.